one and all, respected teachers and my dear friends. First of all, before I begin, I'd like to thank our seminar coordinator, Professor Shaikh sir, and my project guide, Professor sir. Well, the topic for today is an insight into hybrid vehicles, fact or fiction, a real world test. Okay, next. But what I'll be dealing with in this seminar today is, I'll explain to you what is a hybrid, what is the basic need for a hybrid vehicle, and the different types of hybrid. We'll be doing a case study on a Toyota Prius, which is one of the most popular hybrid vehicles available as of now. And then we'll be going into the facts about the hybrid cars, performance, mileage tips and things like that. Finally, a real world test between a hybrid Lexus and a Mercedes CDI engine. Next, what is a hybrid vehicle? A hybrid vehicle is nothing but something which combines two or more sources of power to propel directly or indirectly a certain engine. That is a hybrid. Meaning it's using two or more, it can use either two or more than that to propel a certain engine. Now, everyone, you must be thinking of hybrid to be a very complicated machine, but it's not like that. Everyone must have definitely owned or seen a hybrid in their life. For example, the moped, which is the mobilized pedal bike, the Luna and things like that, you've definitely owned it. That is a hybrid, where it uses the energy from the internal combustion engine and the mechanical energy inputted to the bike by the rider. And then you also have the locomotive, which are diesel electric hybrids. Next. Now, what are the basic requirements? Why do we need a hybrid vehicle? Someone would think, since we have such fine running IC engine cars, why do we need a hybrid vehicle? First of all, we all know that energy resources are running out at an alarming rate. You have the depleting fossil fuel layers, and therefore we need new technology, innovative technology by which our future will be secure. And secondly, the alarming rate at which pollution, the environment gets polluted. So hybrid vehicles does not eliminate pollution as a whole, but definitely it reduces pollution levels by an alarming level. Then, what are the minimum requirements that any car should have? A normal car should at least run 300 miles without refueling, and then it should be easy to refuel, and that process should be quickly done. And then it should keep up with the other traffic on the road. That means it should be powerful enough to go on the freeway and should have good pickup to climb up steep slopes, etc. Next. Now there are two types of hybrids. We start off with a parallel hybrid. Now in a parallel hybrid, you have a fuel tank which supplies fuel to the IC engine. The IC engine is connected to the transmission, the drive mechanism, and then you have a set of batteries which is connected to the electric motor. Now, since the name itself suggests it's a parallel system, so either the IC engine can power the transmission or the battery can power the transmission system. Next. Now we have the series hybrid. Now in a series hybrid, the series is one after the other. So you have the IC engine which powers the generator. The generator can either give power or to charge the batteries, or skip that and directly provide the transmission, which will make the car move. Next. Now this is a very interesting chart set down by Honda. Now what happens here, you can see when the vehicle is stationary, the engine automatically stops. So there is no fuel consumption whatsoever, and there will be an indicator light which suggests that the engine is off. As soon as you step foot on the accelerator, the electric motor and the engine will start. Now, startup and acceleration, it is a dual process where you will have the IC engine also powering the vehicle as well as the electric motor assist. The engine will be rotating at low RPM. Then you have gentle acceleration. Here there is no electrical assistance, it's just the 4 cylinders that are firing. Then you go into the low cruising speeds. Now in the low cruising speeds, you have the motor rotating at very low RPM, and there will be assistance even from the electric motors. Then you have acceleration. Now in each such acceleration, when you're climbing up a slope, you will again have, the motor will suddenly give you that extra push, which is not there in a conventional vehicle. And then when you go for rapid acceleration, again high torque movement of the engine and high torque movement of the motor. Now the interesting part about this is high speed cruising. Now why is the hybrid vehicle not such a successful thing in the US? Because you have huge freeways where you have to maintain speeds of 160 kilometers per hour. So over there, now when you're cruising at really high speeds, at about speeds above 80 kilometers per hour, the electric motor will absolutely not assist you. It will just be your IC engine that's powering you. And then the hybrid vehicle boasts of a very innovative technology which they call as regenerative braking. So what happens is when you're descending, when you're decelerating down the slope, the motor will absorb most of this energy and charge your batteries. So therefore there will be less strain on the engine to do the same. Next. Now let us go for this case study of the Toyota Prius. Next slide. Okay, as you can see there is a petrol engine which is indicated in blue. The shaft of the petrol engine, there are two electric motors to begin with. One is the green one and one is the red one. So the petrol engine shaft is connected directly to the electric motor 1. Now from the electric motor 1, the key component over here which Toyota's ingenious engineering is the power split device, PSD, in the center. So the shaft of the electric motor 1 is connected to the sun gear, as you can see in the center. Around the sun gear is the planetary gears. Now this planetary gear system is connected to the outer ring, the ring gear, which is connected to the salient chain, and the salient chain is coupled with the electric motor 2. Now you can see, now someone would ask me why are those two inverters there? As they all know that electric motors work on alternating current and three-phase alternating current, and all major batteries in the world, like the Toyota Prius, work on DC current. So what happens here, the inverters are required to convert the AC into DC and thus charge the batteries. Next slide. Now this is the inside of engine of Toyota Prius. Now what is the interesting point here is hybrid cars, they work on something known as engine downsizing. That means the Toyota Prius weighing about 1,300 kilos. This is a very small engine for that. So what they work on is a smaller engine, that means smaller capacity, which means less fuel will be absorbed, lighter weight pistons, and thus definitely more and more efficiency. Next. Now the power split device, this is how it's shown. Now we've talked about the series and the parallel hybrids, but the Toyota Prius is a pretty ingenious design, all thanks to the power split device. Now you can see here that the petrol engine indicated in blue is connected to the planetary gears and the outside gear, the outside ring, the blue one. And then you can see the electric motor 1, the green is connected to the sun gear. And then you have the salient chain which is connected to the electric motor 2, which is indicated in red. So now just think of it, anyhow, if you just power the petrol engine, shut the electric motor 1, power the petrol engine that is in blue, those planetary gears will rotate and thus the outer ring will rotate, power the salient chain and thus the car will move. Now if you leave aside the petrol engine, the blue one, you go to only powering the electric motor 1 which is indicated in green. Anyhow, the outer ring will also rotate. So it rotates both ways. So this